Welcome back, everyone. I hope you are all doing well and ready to dive into a new concept. Today, we'll be learning how to solve quadratic inequalities. Before we tackle quadratic inequalities, let's warm up with some linear inequalities. First example is solve 2 into x minus 5 less than 9. First of all, we will expand the bracket, we'll multiply 2 by x and 2 by minus 5. So we will get 2x minus 10 less than 9. Then we will take this minus 10 on other side, so it will become plus 10. So this will become 19. Then x is less than 19 divided by 2. X is less than 9 whole 1 upon 2. We have to solve inequalities in the same way as we solve equations. There is just one difference which we'll be discussing in the next example. Solve 5 minus 3x is greater than or equal to 17. First of all, we will take 5 on other side. So this will become 17 minus 5, which will be equal to 12. Then we will divide this 12 by negative 3. Whenever we divide or multiply by negative number, then the direction of inequality is to be changed. So previously it was greater than or equal to, now it is less than or equal to. So we have x is less than or equal to minus 4. Important rule: whenever you multiply or divide both sides of an inequality by a negative number, you must reverse the direction of the inequality sign. So whenever you will be solving quadratic inequalities or linear inequalities, you have to make sure that whenever you are multiplying or dividing by a negative number, then you have to reverse the direction of the inequality. We have done examples related to linear inequalities. Now we'll be solving quadratic inequalities. There are certain steps which you need to remember for solving quadratic inequalities. First of all, you have to factorize the quadratic expression. Then you have to sketch the graph, that is parabola, and you have to identify x-intercepts. Then you have to determine where the graph is, whether it is above the x-axis or below the x-axis. And then you have to write down the solution for the required region. We will be solving some examples related to quadratic inequalities. Important notes for solving quadratic inequalities. If a quadratic inequality is given in this form, x squared is less than 16, then we don't have to take square root on both the sides. This cannot be done in quadratic inequality. Instead, we have to take 16 on this side, and then we have to apply identity to factorize it. We have here x whole square minus 4 whole square less than 0. Then we can write x minus 4 and x plus 4 less than 0. Another important point is, do not apply equation methods like either or for inequalities. You cannot write x plus 3 is less than 0 or x minus 5 is less than 0. You cannot write this in quadratic inequality. Instead, we take out the roots, we sketch the graph, and then we write down the final answer. Let's solve some examples. We have x squared minus 7x plus 12 is greater than 0. It is quadratic. So first of all, we have to factorize it using middle term breaking. We'll multiply 12 by x squared. We will get 12x squared. Then we have to make factors of 12x squared in such a way that when we add or subtract, we get minus 7x. So the factors here are 3x and 4x. When we multiply these together, we'll get 12x squared. And when we will add these two together, we will get 7x. But here we have minus sign, so we will put negative sign with both the numbers so that we can get negative 7x. Then x squared minus 4x minus 3x plus 12 is greater than 0. Then x is common, x minus 4 minus 3 is common, x minus 4 is greater than 0. Then we have x minus 3, x minus 4 greater than 0. After this step, you are not supposed to do the same thing which we do in equations, that writing x minus 3 is greater than 0 and x minus 4 is greater than 0. Instead, we have to take out roots. Roots here are x minus 3 is equal to 0 and x minus 4 is equal to 0. So we have x is equal to 3 and x is equal to 4. We will mark these on graph. If we consider 3 here and we consider 4 here, as we know, the coefficient of x squared is positive. So the curve would be a minimum curve. So we will be drawing a curve like this. It opens upward. As x squared minus 7x plus 12 is greater than 0, so we have to consider the part of the curve which is above x-axis. So this part of the curve we have to consider. The value of x on this part is greater than 4. The values of x on this part are less than 3. So we can write down the solution as x is less than 3 or x is greater than 4. Let's do another example. X squared minus 6x minus 16 is less than or equal to 0. First step is to factorize it. For factorization, we will use the same method. We will multiply 16 by x squared to get 16x squared. We make factors in such a way that when we add or subtract, we get minus 6x. Factors of 16x squared are 8x and 2x. When we'll subtract these two, we'll get 6x. But we have here minus 6x, so minus sign is to be with the greater number. So minus 8x plus 2x minus 16 is 0. X is common, x minus 8 plus 2 is common, x minus 8 is less than or equal to 0. Then x plus 2, x minus 8 is less than or equal to 0. Then we have to take out roots. X plus 2 is equal to 0 and x minus 8 is equal to 0. So x is equal to minus 2 and x is equal to 8. Now we'll mark these on grid. Minus 2 we can mark here. 8 we can mark over here. Then we can sketch the curve. As we can see here that the coefficient of x squared is positive, so the curve is to be minimum curve. So we can sketch a curve. Now, as we can see, the sign here is less than or equal to, so we will consider the part of the curve which is below the x-axis. And on this part of the curve, the values of x are in between -2 and 8. So these are the values of x which we have to consider. As we have here less than or equal to sign, so we will write the answer as x is greater than or equal to -2 and less than or equal to 8, as the values of x are in between -2 and 8. Let's do another example. In this case, it's already a factorized form. We just have to take out roots. We have to sketch the graph and then we have to write down the solution. For roots, we have to equate x minus 2 to 0 and 5 minus x to 0. Then we have x is equal to 2 and x is equal to 5. Now we'll mark these points on the grid. We have 2 here. We have 5 here. Now we'll see the coefficient of x squared. If we'll multiply x by minus x, we will get minus x squared. So here the coefficient of x squared is negative. So whenever the coefficient of x squared is negative, then the curve is to be maximum curve. So we will draw a curve like this. Now, as there is greater than sign, so we have to consider the upper part of the curve. And on this part, the values of x are in between 2 and 5. So we will write the solution as x is greater than 2 and x is less than 5. Let's do another example. We have x squared minus 96 is greater than 0. In this, we have to factorize it using the identity. We can write it as square root of 96 whole square. As we know, square root of 96 whole square will give the result as 96. So we can write it as square root of 96 whole square so that we can factorize it as x minus under root 96 and x plus under root 96. Why we have done this? Because we cannot take the square root in case of inequality. Let's take out the values of x. Let's take out the roots. X minus under root 96 is equal to 0 and x plus under root 96 is equal to 0. So x is equal to under root 96 and x is equal to minus under root 96. We can write it in simplified form as well, which is 4 under root 6, and this is x is equal to minus 4 under root 6. Next step is to sketch the graph. For sketching the graph, we will mark these roots. We have here minus 4 under root 6. We have here plus 4 under root 6. As the coefficient of x squared is positive, so the curve is to be a minimum curve. And we will sketch a curve. Then we will sketch a curve. We can see sign is greater than. which means that we have to consider the part of the curve which is above the x-axis. On this curve, the values of x are greater than this, and on this part of curve, the values of x are greater than this. So we can write down the solution as x is less than minus 4 under root 6, or x is greater than 4 under root 6. Let's solve a complicated inequality in which we have to do expansion first. We have to bring it into the form ax squared plus bx plus c less than 0. And then we have to further solve it. So first of all, we will expand left-hand side. We will multiply x by 1. We will get x. X multiplied by minus x is minus x squared. 3 multiplied by 1 is 3. 3 multiplied by minus x is minus 3x less than x minus 1. Then we have here minus x squared minus 2x plus 3. We will take this minus x on this side and minus 1 on this side. Now we have here minus x squared minus 3x plus 4 is less than 0. To make this x squared positive, we have to multiply the whole inequality by negative 1. And whenever we multiply inequality by negative number, then we have to reverse the direction of inequality. So here we will get x squared plus 3x minus 4 is greater than 0. Now we will do factorization. Here it's easy to do factorization because we have here minus 4x squared, and the factors of 4 are 4 and 1, which we will subtract. We will get the result as 3. As we have positive sign here, so the greater number will have positive sign and the smaller number will have negative sign. We'll take common x plus 4 minus 1, x plus 4. Then we have x minus 1, x plus 4 is greater than 0. X minus 1 is equal to 0. X plus 4 is equal to 0. We have taken out roots here. Then x is equal to 1 and x is equal to minus 4. Then we have to sketch the curve. We'll mark here minus 4. We'll mark here 1. If we see this step, here the coefficient of x squared is positive and the sign is greater than 0. So we will be considering it as minimum curve. We will sketch the curve. As the sign is greater than 0 here, so we will consider the part of the curve which is above the x-axis. On this part of the curve, the values of x are less than minus 4. On this part of the curve, the values of x are greater than 1. So we will write the inequality as x is less than minus 4 or x is greater than 1. Let's solve another example in which we will be solving compound inequality. There are two inequalities given. We have to solve these two inequalities. We have to find the set of values of x which satisfy both the inequalities. First of all, we will solve this inequality. X squared minus 11x plus 24 is less than 0. We'll solve it by middle term breaking. When we'll multiply 24 by x squared, we will get 24x squared, and the factors of 24 are 3 and 8, which will give the result as 11. So minus 3x minus 8x plus 24 is less than 0. Then we will take x as common. X minus 3 minus 8 is common. X minus 3 is less than 0. Then we have x minus 3, x minus 8 is less than 0. Then we'll take out roots. X minus 3 is equal to 0 and x minus 8 is equal to 0. We have x is equal to 3 and x is equal to 8. We'll solve this inequality. 2x plus 3 is less than 13. 2x is less than 13 minus 3 is 10. So x is less than 10 divided by 2, which is 5. Now we'll sketch the graph. For this, we have 3 here and 8 here. As the coefficient of x squared is positive, so the curve is to be minimum curve. And we have to consider the part of the curve which is below the x-axis, as we have less than sign here. The values of x on this part of the curve are in between 3 and 8. So we have here x is greater than 3 and less than 8. For this inequality, x is less than 5. We can consider 5 over here. All the values less than 5 are the values of x for this inequality. So the values of x which satisfies both the inequalities are x is greater than 3 and less than 5. The values from 3 till 5 are the values of x which satisfies both the inequalities. So our solution set is x is greater than 3 and less than 5. Thanks for watching the lesson on quadratic inequalities. If you found this video helpful, give it a thumbs up and subscribe to the channel for more clear and concise math tutorials. And if you have any question or topics you would like to see covered, drop a comment below. Keep practicing and stay curious.